Today, I'll be here to talk about refactoring in Python, about working with old code that has been left to you. It doesn't have to be old as in age, it just needs to be old as in quality. So what's the point of refactoring? The point of refactoring is getting your code to actually be maintainable, to do new features without fearing for the stability of the project, for fearing the release. It's mostly about focusing on having code that you can develop confidently and that can work when you expect it to work, to not have these silly surprises. The most often suggested method is just rewriting everything, but that's not always a good thing. That's not always a benefit. We shouldn't throw away production code because it has worked in production, it has worked for months, years, decades. It has done its job, and throwing it away would throw away a lot of stability that any company needs. First, a couple of things about me. I'm a team leader at Kiwi.com. I'll talk a bit about the company in a moment. I like doing software architecture. I like solving big problems that don't relate to code itself, although I love coding too. I like fragmenting problems to many smaller parts, then solving those parts independently and just general solutions. I've worked with edX, with Extension Engine. Some of you might have heard of it. It's an open source learning platform. I've had some play projects before that, and now I work with Kiwi.com. We are a company that works on making travel better. Our vision is to make travel super accessible, super simple, to cut out the middleman, to reduce all the that's thrown at you, and to make it just work. We're focused on tech because our solution works via interlining different airlines technologically. Our search is searching through many different airline providers, and generally our stack is Python with some mixing, some friends, some C, some Go, generally, but mostly Python. Virtual interlining, as a principle, is just mixing airlines that don't usually work together into these large itineraries that combine different providers, and it's pretty difficult problem to solve. Well, we solve it, we sell flights like that, and check us out if you have time. Now, I'm going to talk about reading old code, reading code that you've inherited, things that you have to develop, and that you haven't written yourself, or sometimes you have, but you've forgotten, and to find out the secrets that code can hide, the exceptions, the little tricks and tips from previous developers. I'm going to mention now the Chesterton's fence. It's a Wikipedia fallacy, let's call it fallacy, about a fence that is put across the middle of the road. And the rule should be not to remove the fence because it's in the middle of the road, but to ask yourself the question, how did it get there? What is it blocking? Maybe the road's ending, maybe something is happening. Basically, don't touch things until you understand why were they put there. Things that look useless often end up not being so. And I'm going to talk about incremental changes, about changes that should be taken in steps. Steps to better code, to better product, to better everything. I'm also going to touch on to testing code, how testing is a good guideline to having good quality code, how it forces you to make dependencies, systems, relationships, all these concerns separate, and it forces them to be opaque, so you can see them. They are there, and you see exactly what you're working with. I'm going to do this with this general topics, and I'm going to throw some specific examples in the mix, sometimes touching on Kiwi.com code, sometimes touching on our policies, things like that that we use, some of our tools, and I'm going to go through three different sections, starting with the easy wins, That's mostly tools and similar, then patterns and anti-patterns, some code, and in the end, I'll end up with philosophy and policies, things we do as a company that make us do these things better. I hope all of you will find yourself in at least one of the categories. Some of you will see yourself in all of them. Let's start with the easy wins. Easy wins are supposed to be easy. It's supposed to be something that a single developer can push for, company can add, and it'll all work better. They are plugins, libraries, utilities, software that helps you do your job much easier, and it's not complicated. It's something anybody can do. But it dances around the root cause. It's not a fix for problems, it's just a step to get there. One of those things is automated code quality. Most of us have used some tools to increase the quality of your code, to have linters, to have specific checks, to do all these automated things that make it much easier to work. They're important because they let you do one decision, one process, and then save time later. They reduce arguments about specific parts of a development process. They let you decide once and for all important things, so you don't have the same discussions repeatedly. Some examples are PyLint, MyPy, Black, Koala. How many of you have heard about all of these? Raise your hand, please. Ah, cool. Around half the audience. Well, let's start with PyLint and MyPy. Most of you have heard of these. They are static code analyzers. Most of these tools will be static. PyLint lints code according to some rules. It checks these rules and then checks if your code follows them, then marks code that doesn't. It's established industry practice, and I consider it the bare minimum of any serious code. You should lint it and check out what it says. If it works, great. You should aim for the maximum score, not even warnings. However, many companies don't automate it. Many companies just run it over their code. Sometimes people forget, sometimes there's an incident or two, but it's super easy to automate. Any continuous integration suite has it as a default, so yeah, do it. MyPy checks if MyPy is a tool that allows you to add annotations to your code. Well, you can add annotations, but MyPy checks them. And those annotations in code show what types your functions are taking and returning. What's great about MyPy, and why I mention it, is that it's an opt-in tool. So many people don't like typing in Python. Many people disagree with typing in Python. However, MyPy allows you to just type things that you can. It doesn't force you to convert your whole database to this typing paradigm, but it lets you fix little by little, so the transition can be gradual, so your code can grow slowly but surely to something that's easy to read. And yeah, it's super easy to implement straight away. Start with a couple of functions, make it grow step by step until your whole code base is eventually covered. I'll mention a tool called Black. How many of you have used Black? Not a lot. All of you should start. Basically, Black is an automatic code formatter. Many different languages have these. Python is sorely lacking in a standard for these. Black keeps code style consistent. It formats white space, it formats argument lists, etc. It's super simple to run. You just call Black, and it doesn't have a configuration. It has this code style that has been collected from most style guides. It's a merge of all of them. There's no config. You cannot choose whether to use it specific way, so it keeps all the code formatting equal. It doesn't allow two different code bases to differ even. And that's a great thing about it, because you don't have these arguments about unimportant things. You don't have arguments about how many arguments are allowed in a single line, etc. It just does it syntactically. So if something is logically connected, it's on the same line. It doesn't allow you to do fascicle, sorting, something for beautiful code. It doesn't allow it. Sometimes it's ugly to people. People don't accept that syntactic formatting is the best. However, after 2 days even, it'll just phase out. You will see the code, and the benefit is that you will never again have to argue about sorting variables or breaking new lines. It's a great win. And the great thing about it is that it keeps the same interpreter output. The syntax map stays the same, which means all the code you run through Black is always the same. It doesn't make meaningful changes to your code, so you can run it on any code base, well, excepting some super hacky stuff, but on any code base that, and it will always have the same output. It cannot break your code just by formatting it. Now I'll mention Koala. Koala is a bit more advanced tool or a set of tools. It's a framework for adding these so-called bears, Koala bears, into your pipeline that has modularity. Each bear does a specific check. Those checks all check your code in a specific way. It's a great tool for adding these pipeline steps that would be a pain to implement on their own. To have these small checks independent, like an import sort, etc., would just make your continuous integration huge. Koala has a bear for most of these, and then you can just put them all in and run them via a single command. What I like about Koala is that it, by default, imports some complexity check bears, which work great. And locally, you can run it to automatically fix most issues, which yeah, increases your efficiency. I'm going to show an example of all these tools run. It doesn't show too well, but it's readable enough. Basically, it's a play example, but copied from parts of production code, each of the parts of the incident. You have thrown away arguments. They don't make sense. Formatting broke a little bit. You have these commented out lines of code. You don't know what the function does. There's some print in there. There's at the end a hanging return. Basically, it's messy. After running through all these tools, it automatically just converts it to a new line for all the arguments. It forces you to type it. It forces you to list what types are going to be used in the function. It requires you to make a docstring, which many people lazily just skip. It requires you to return a single thing, or to return in every code flow, so to be explicit, which is in spirit of Python. And it forbids you from printing out things. It requires you to log them instead. Basically, it lets us enforce a lot of comments that would be there in a code review through automated tools, saving everybody time. The conclusion is that these tools remove a lot of complexity. A lot of you have done code reviews. How many of you do mandatory code reviews in your company? So almost all of you. Basically, a lot of you spend time looking over somebody else's code. And often you'll see patterns with people. People make same mistakes. People oversee things. They forget to put a docstring. They don't type, and you need to type. Generally, there are small things that repeat, and you cannot blame people for happening, because people are people. We are imperfect beings. While tools remove that discussion. They perfect the process by automating it. You think more about real problems, and you think less about superficial stuff like line breaks. It's an easy bump in code quality, but it doesn't fix the core issues. It doesn't fix the problems with your code that make your life troublesome. For that, you need to start thinking in patterns, in code that's in seeing why your code is really hard to use. Why is it hard to read? One of the things that you think about most is reading code that does a completely opposite thing than you expect it to. It astonishes you. It surprises you. That's the principle. That's why it's good to follow the principle of least astonishment. Bring a new person. Let them read your code base, and if they're rolling their eyes every 5 minutes, you know you have a problem. Basically, the more surprising facts you have in your code, the more smart hacks, that code is worse. Legacy is often astonishing. A lot of you probably work in post-startup companies that originated with 5 guys in their garage who just made code to get it to production ASAP, and they did some astonishing things. They often call them historical reasons. And those historical reasons make our life a living hell. Basically, what you need to do to get through them, to fix them, is to start introducing some good patterns and anti-patterns. Well, patterns, and removing anti-patterns. One easy way to recognize this are code smells. It's a lingo, and code smells generally show code the smells of neglect, inconsistency, redundancy. You figure out, these are the symptoms of some bigger problem. And they're usually because of these things: deadlines, prototyping, a manager dropping in saying, we need to release this tomorrow. It needs to work. Everybody takes shortcuts then, and usually these shortcuts hide somewhere and they start smelling after some time. Worse and worse. There are 3 levels, basic levels. Easy ones are the things you can fix in a small commit, couple lines of code. There's no scope to them. That's mostly when people just rush to release something and they oversee things. These are halfway removed by using automation. They're super easy. They're not the concern you have. Medium ones are the mistakes of architecture, the mistakes of having a scope that was developed on the go. You just kind of figured out what you're gonna release, and it went out with time, and in the end, it ends up balancing on a couple of things that shouldn't be designed this way. And then you have these, what I call them the hard smells. They are super easy to notice things. You notice them in your code every day. We should fix this. Yeah, but nobody knows how. Nobody knows how to remove that huge framework you're depending on without breaking everything. They usually are the motivation people go, let's rewrite. Let's dump the code base, let's start again. Some examples would be here. These are examples from our code. We had some airlines that had fixed currencies if they were our affiliates. And for example, these airlines used rubles. And then we checked them, and it started with the Alpha airline. Somebody set the currency to ruble. Then tomorrow, or in a month, or in a year, there was another airline, and the guy just added another elif. Then tomorrow, another one came, there were more elifs. These are just 3, but there was a lot of them. For most airlines that had this rule, there were specific else ifs in the code. And it piled up. At the start, it was 2 airlines, nobody cared, but it became a pattern, an anti-pattern, that you just add a new airline as another elif. It needed fixing. It was easy, but people just usually didn't care. These are the super easy ones to fix. Then you have the medium code smells, the ones that are also obvious, but quite hard to do. And they establish themselves as big anti-patterns, as big things you do in your code. For example, here we had an order method that took in a data dictionary and returned out an untyped, just anonymous dictionary. Basically, it did a lot of things, and it did them all by muting this one magic big dictionary. And that's a hard problem to solve when you don't have a proper documentation, when you don't have it all written down. You don't know what you're gonna get out of the function. It's pretty hard to maintain. And slowly, we're also working on fixing these. But the problem that appeared after a couple of months of fixing them was that people would see this in code, and they would just reintroduce it. They would make a new function that worked similarly, because that's how things are done here. That's how you do things. And that's a big problem that needs solving via education and rules, as well as just rewriting it. It's something that respawns in your code. And then we have a hard problem of us starting out with pure SQL, and then after some years you have to implement some ORM. And that's a hard problem. When you work everywhere with SQL queries and raw SQL, implementing an ORM becomes a big problem. We did it by replacing the raw SQL by SQL Alchemy, which is pretty down to the metal still, but it helps you validate returns, etc. It's a great thing to have. But we started doing it step by step, and we managed to. How? We started by using some software patterns, but I'll get to that part. But before that, I'll mention SonarQube as a tool that we use to check out for code smells, to find out these symptoms in our code that need to be fixed and to have an overview. It's another static code analysis tool, but SonarQube is quite advanced. It's a whole product that they sell. It analyzes known bugs, things that have been recognized in the Python community as bugs. It finds code smells. It has security oversight detection. It tests test coverage, complexity. It asserts that you have comments and documents everywhere. It's a pretty overall set of tools. We don't use the full suite, but we use the checkers. What's great about it is that it integrates with most Git hosts. So it directly comments on your merge requests, so the reviewer doesn't have to. It checks out things like name length, common abbreviations, things that you know that need to be fixed, but you want something to point it out. And it also has a list of all these errors listed. So you can have somebody start maintaining the code by just going through the list and striking off points one by one. It's a great newbie task. And to make it even better, it has documentation of everything in the interface, so you can figure out exactly why did it warn it, with examples and links to more documentation. But let's go back to the anti-patterns. Most code smells happen because of some anti-patterns, things that sounded like a good idea, but didn't have enough thinking. They're usually unique to each code base. Each code base has these things, the ways we do things here. They happen because of starting out in a garage, not having a design process, just like people figuring out as they go along. It's mostly because of organic code growth. You grow your code day by day, week by week, and it kind of just grows all around. And people usually do some copy-paste coding in the meanwhile, figure out this is cool function, let me copy it, changes things here and there. They don't bother about polymorphism, they don't bother trying to put it down into an object class. They don't care, they just copy paste it. Sometimes that's the way to success, but people get to clean up after them. Some of them we've had are these magical methods, like the one I mentioned with the data. They lack explicit input and output. They're usually a lot of side effects just implemented there as a thing that happens. They get fixed by approaching a better code object-oriented coding approach, but usually they hang around for quite a long time. They do all these cleanups, all these rollbacks in your database. Basically, they just reset the state of your function somehow, of your code, and they seem like a cool tool to have until you have to test them or debug them. Then they just don't work. They work in production, don't touch it, and people avoid replacing them. Eventually, you do have to. We also had a case of decorators that went wild. They had a lot of importance in some parts of our code base. They modified function signatures. They weren't explicit. Basically, you had a function with 3 lines of code and 7 lines of decorators. And yeah, it was quite difficult to debug because decorators themselves aren't meant to be debugged that well. Basically, there's supposed to be a helper there, but some people thought they were cool and just added a lot of them. Those were some examples that we found around in code, and I'm pretty sure these are quite specific to our code base, as most anti-patterns are. But eventually, you want to have bubbles of clean code arise with these. A couple of functions that don't do those decorators. A couple of functions that do real typing, real signatures, that don't do side effects. And that's hard when your code is a big interconnected mess. It's hard to maintain and it's almost impossible to test because everything everywhere is connected all the time. You cannot just, your tests start becoming trivial when you have to mock 90% of the lines. And the solution to this is starting to implement it properly, starting to isolate things you can, functionalities you can, into these separated bubbles, I call them. They can be tested, they can be reliable, they can be covered, and then you just interface between them and the messy code, little by little, growing your bubbles, caring for them, then expanding them, and eventually they will outgrow the old code and get somewhere where you can maintain things without worrying. And as a benefit, when you have to change code in these bubbles, you can do it much more reliably because you covered it with tests. Patterns to help these bubbles, these testable safe spaces in code, are mostly separation patterns. These new code needs to flourish, needs to be able to be written, to be contributed to. So you usually have to set up some interfaces and facades between the cleaner code and older, I'm not going to call it shittier code, but oops. And basically, what the thing is that you cannot just throw it all away. You have to separate it slowly and surely. I'm not going to talk about specific good code qualities today because there are a million talks about that. I'm just going to talk about separating what you've written well from what somebody else has written worse. When I mention an interface, I don't mean an interface as in Java interface or C++ interface. I mean it more as a common usage of some code pattern. You notice that these parts of code are all used in the same way, but they have 17 different functions lying around all the pieces of the code. Then you should try to find the base use case, the default flow, and create some kind of an interface, some abstract base class that would just say, this part of code needs to be initialized, it needs to be run, it needs to do these checks, needs to commit these changes, then needs to clean up. And once you have this basic use case, then you can create some kind of an interface in your code that will allow you to rewrite it in an object-oriented approach and just implement this convention on writing this code. And then you add all those edge cases from the old code as some different implementations. That allows you to slowly approach mapping your processes to actual separate functionalities in your code, separate implementations of classes, rather than just a lot of messy conditionals. And as eventually you add these edge cases back into the base interface, you figure out how your process functions. You figure out knowledge about your code, what's really important to keep developing it. And then after you start up using these cool things, these classes and stuff, you need to kind of separate them from the bad code. You need to figure out a way to interact with these. These are mostly done by facades and inverted facades as a figure in programming. You basically, in a Python, that would mean defining a module, defining a file that would import your old code, and then that old code would be used in the new code via these magical methods that do all the side effects, but you keep them in one place and it's obvious. Everybody sees exactly where you're messing it up. Then that may require some hacky implementation, but the plus side of it, bonus, is that you're setting up a contract. You're setting up how it's supposed to look, and then by having that contract, by standardizing that access, you're showing what it's supposed to look like ideally. The problem of these respawning issues in code is that nobody knows what it's supposed to look. By throwing out some facades, by setting up the image of what it's supposed to look like, how it's supposed to be used, you set up the ideal state that people who write the code can vie for, can go for. And then people will just naturally adapt, hopefully. Then testing an old code base is always a problem, but Tests are super hard when you have a bad code base, when you have a code base that's interconnected everywhere and doesn't have separation of concerns. But they're very useful. They're worth all the effort because they allow you to develop your code with confidence. They allow you to make changes and know if they break something. Common pitfall is making testing a charade. Testing everything and mocking everything is not really useful. If your methods are mocking the main things in your code, the main interactions, you're just writing tests for the test's sakes. I suggest going through tests from outside to in. So don't follow the hype. Don't start with unit tests. They're not really useful if your code base isn't covered with tests. It's better to start trying to make some smoke tests. They're like a smoke alarm. Make something that calls most of your code, so a breakage is obvious. Then move on to integration tests, pathways that a user interaction would go through in the code. And at the end, finish up with unit tests where they are useful, so you don't waste a lot of time writing these more specific tests that in the end just don't assert anything. They don't help you know that your code is working. By starting to do tests, you instantly figure out that a functional approach to programming actually helps a lot. So you see these side effects like a bad thing in code, and by refactoring code to accommodate tests, you also accept a more quality code approach. It's just writing tests helps you have a good guideline to quality. It helps you know that the code you're writing will work and is good. Is reusable. So in conclusion, patterns and end patterns, it's almost never pretty after growing a lot. It's a mess, but we cannot really throw it away. We have to improve gradually, whittle it down little by little, and build these bubbles of quality code. Build these things that we know will work, and later spread them around, make it all fit together. However, after going through code, after adding some cool tools, you figure out that all the theory is good, all the talking to your colleagues is good, but you need to implement it somehow. Rules need to be established, and if they don't exist, if they aren't enforced somehow, they may as well not exist. You'll try to talk about clean code, about everything, then somebody will just come and mess everything up. I will add some in KiwiCom notes here that describe how we've solved these problems I'll be talking about generally. Basically, you need to teach people to approach problems slowly. That rapid changes, attempting to rewrite the whole code base, don't help anyone. They're hard to review, they're hard to check, they're hard to manage, hard to test. Basically, you get a lot of problems when you have somebody dropping out a third of your code base, rewriting it in, I don't know, GraphQL. Basically, the old code worked so far, it's still working, keep it working, and then incrementally adapt it to something newer. There's no worse thing for a manager to see than a huge change that you put a disclaimer, it may break everything. It probably will. Establish code review rules. Establish a standard process, split responsibility, require tools to pass, the tools we mentioned, add them to automation, that's great, that's going to help everybody, and by having a proper code review, you reduce the bust factor. You reduce the point of failure of your company. You don't have this god developer who's going to leave, and if he leaves, the company pretty much fails. If you try to enforce these things, especially if you enforce it via CI, it helps a lot. We require reviews before any code can be merged, before anything can be released, and we run all these tools, and they have to pass before your code can get to master. Some best practices with reviews is that it has to be impersonal and blameless. You cannot flame people while reviewing. You need to talk about the code, not about the people. Otherwise, it can lead to a very toxic community if you allow people to just insult each other. Also, errors, mistakes in development need to follow blamelessness too, but we'll get to that. And I suggest a triple tier system. When you review code, you first should look over the overall scope. Don't get into the details until you know that the code does its job, until you see that this new feature is implemented this way. It's not just made up, it's quality code that will do its job. Then you should look at the system scope. Does it fit the overall picture? Is it starting a new feature when some older one will do? Is it trying to reinvent the wheel? Things like that, things that would make you nix hundreds of lines of codes. And then at the end, you look at the code itself. You see if it's written, if the logic makes sense, if there are needless loops, etc. But the problem with code review loops that I've seen is that usually people focus on the small details because they're easy to spot. You just scroll and you notice, he's using list comprehension instead of dictionary comprehension, etc. You figure out these small mistakes and you pat yourself on the back thinking you've done a good job. You usually don't. It's important to educate developers, to make everybody know why you're doing what you're doing, to understand the why, to enforce documentation, to show people how the ideal state looks like, to explain the direction of the company. Here we do, in Kiwi.com, we do it by having monthly talk sessions. We have all devs meetings where we sync the whole company. We provide our developers with an education budget to go to conferences, to network with engineers. We force tech writing culture. We have a whole team of tech writers who document code, help with documenting code, and require documentation to be up to date. And we enforce public discourse. We require all conversation to be public in our open channels. We don't want releases to be done by two people at a computer talking about how they're going to change the company. We want it to be open in a channel where everybody can check it out, when everybody from their subordinates to the CTO can read up on what's happening. It lets people know the overall direction, the overall state of the company. There's no easy victory in these things. There's no winning it all overnight. Quality increases slowly, step by step. Those test coverage numbers go up by 1, 2, 3%. They don't go up by 20, or else you're doing it wrong. And tools cannot replace real engineering. In Kiwi.com, we try to put our attention to our product mostly. We do projects that modify it, but the attention is that the product needs to stay stable and our customers needs to stay happy. We also try to write code that's replaceable, that can be thrown off and undone in a moment. Best code can be rewritten easily. It can be dumped out in a moment when things go wrong, when the feature is not worth it, when you need to deprecate something. It needs to be easy, because if it's easy to throw something out, it's usually easy to reuse it or replace it in the future. At Kiwi.com, we do that by forcing every product, every feature to have some MVP established, to have something modular that can be kept or thrown out easily. Then it comes to the interacting with management, explaining how does code debt hurt. It's a real debt. That's what most people don't figure out, that eventually things crash down. People start developing slower, mistakes happen more often, implementation is slower, and it's mostly a problem if your management is micromanaging developers. It's requiring you to do these tasks that bring new features in, and they don't allow you some reflection time. At our company, we figure out that if your manager just wants to get the tasks done, you give him the evaluation, where you always include some time spent to do it well, to fix some bugs, to fix up some code debt. And that's also a thing with management. They usually need convincing. We need the examples. Why do we do this? Why do we fix this? Why do you spend time rewriting something that works? It's because of mistakes that cause issues, that cause the services to stop, to cause customer loss. It's mostly and most easily done by using an actual chart by showing how much money was lost because of this mistake, how many customers we've lost because this didn't work well. And always blame the code dev, blame the hard to write code, hard to interact with code, and not the developers. If you cannot figure it out, that's mostly the fault of the code base, not of the developer himself. He tried his best, it just didn't work out. And in KiwiCom, we try to have a blameless environment where a developer, unless especially malicious or targeted, will never be blamed for making mistakes. The conclusion of this philosophy is that low quality code is usually just a symptom. And we need to aim for the cause. We need to fix what makes low quality code respawn, come back to the code base, and make a mess all over again. It's more important to have consistency, to consistently improve your coverage, to consistently improve your tool set, rather than have this big framework you release once and it works. It rarely works. There's no easy victory in these things. There's no easy conclusion. And overall, you need to follow the story of old code. You need to follow why many examples of code worked like they did. The whole system needs to modernize. It cannot just disappear. It cannot just be rewritten. And you need to figure out where to get easy points, where to implement a tool that can fix a problem, and where to start rewriting things in small, consistent bubbles. And it's very important, after you start rewriting other things, to maintain the quality going forward, to enforce the policies that will make new code added to the code base just better. And I hope some of you will figure out some of these things, grab a couple of tools, implement them, add a policy or two to your company, and we'll just have a better community overall. Thank you for your attention. Do you have any questions?
Perfect. Thank you very much. So, questions? Yeah, already.
Hey. Thanks for the awesome talk. You said that it is important to enforce some policies. How do you enforce them? Have you ever tried to make your corporate linter or something like that?
Excuse me, I didn't hear the...
Corporate linter or something like that.
We actually have all these tools set up in our continuous integration. You cannot actually pass code into the master unless it all passes. It has to pass, and it's all configured in a central place in our repository, in config files.
I'm talking about specifically special rules for your business process or for your content understanding. Like.
Yeah, we also keep repositories with rules, with a handbook for employees that they have to follow while doing these different processes, while code reviewing, while checking other people's code, while resolving problems. Incidents are managed from a certain handbook that has to be covered step by step. There has to be an research of the problem. We also follow the 5 whys. If a problem happened, why? Why did the why happen, etc. 5 times. If a server went down, why did it go down? There was a mistake, why did the mistake happen? It got released, how did it get released? Why it was approved? Why it wasn't noticed by our tools, etc., etc.
Thank you.
Thank you. Okay, question for me. How long it regularly takes for the new employee to get into your working processes, to learn all of your handbooks and all of this stuff?
I'm actually mentoring a new employee right now, and I'd say he took around 2 to 4 weeks to just figure it all out. He could start contributing after a week already, because it's pretty hand-holdy. It doesn't allow him to just randomly break things, and if you just follow all the guidelines and do the CI properly, you cannot just make mistakes that easily. And I'd say around 2 to 4 weeks.
Okay, thank you. Any more questions? Yeah, already 2. Okay.
have you got any tips on tools to automate some of like the stuff like the linting and that kind of thing? So often a lot of people create like PR hooks on GitHub to do some of these changes. Do you have any recommendations on freely available services online that run these linters and things for you?
We pretty much use GitLab, which has all these things like out of the box, but we do have a corporate package for it. I've seen good results done with Travis, used to automate most of these tools. Other than that, not really. Also, Tox is pretty useful to have a similar image on your local machine and the CI pipeline, so you can run one tool that will automate all else.
Thank you.
Hello, thank you for your speech. Tell me please, according to your experience, what is the best practice of code reviewing? Should code be approved by all the team or just half or at least one member?
Usually there's not enough time in a project to get the whole team to chip in. We try to have one other person check code before it gets approved. Sometimes when it's critical code, we try to get 2 or 3 people to check it out. And we usually split the responsibility between somebody who just goes over the top level, some senior, super senior, one of the guys who set up the historical reasons. They check it out if it'll break things. Then we have another person to go micro on it, to check the syntax, to check the small level details.
Thank you.
I like the super senior thing. I need to put it to the resume. Okay, any more? Okay, so that's all. Thank you very much. But you need to choose the best question.
I would like to give the book to the last question.
Okay.
About code reviews.
Okay. Yeah, I don't know which book should be. Okay, this one. Yeah. Okay. And gifts for you.
Thank you. Thank you once more, people, for the attention, for your help. I'll meet you outside.